Sounds awfully grand when I'm introduced in this way, but really I have to explain it is not really me. Okay, I was just had the idea. A lot of other people made it possible. About exactly 10 years ago, I was in charge of a European project, and we invited a panel of science leaders from across Europe to look at the scientific evidence when we show differences for results and outcomes based on the differences for women and men. And we asked them, what did it mean for science? Because we knew it meant something for women, but we didn't know what it meant for science. After 3 months of deliberation, they came up with a conclusion. And that, as I will tell you what the conclusion is. If you want to know more about the process, you can ask one of the keynote speakers who is here, Kurt Rice. He was on that panel, and he has actually then went to his university, which was Tromsø, and used the lessons he was vice president for research, and used the lessons to actually make changes at Tromsø. He can tell you that as well. Okay. So, reason why this panel of science leaders became concerned and recognized that actually gender is an issue for science is because they identified that science has got much more evidence for males and for men than for females and women, and therefore outcomes for research would be frequently worse for women. And there's evidence for that. And then not only did they recognize this and came up with this new way of looking at gender issues in science, they wrote to the European Commission and they said the experience that they just went through should be made available more widely, and hence this idea of Gender Summit was born. The European Commission has responded to this scientific advice, and over the last 10 years, a strategy has been developed that in the next panel, you will hear from one of the speakers, the Ambassador Blinker. So if you're just looking at this slide, okay, just concentrate on those figures where it's kind of a dark blue and gray. This means there is either only males being involved as subject, or the scientists have not reported data segregated by sex. What it means is that a lot of studies cannot be replicated. This means that basically it cannot be meta-analyzed, and there's more or less a waste of money. Okay? Because what we're getting is approximation of our understanding, and approximation is not excellent. And so if researchers don't report the details of the subjects that they study, this research is not useful. And one of the speakers here in one of the session, Hyun Park from Korea, will show you also more about the fact that if you're working with cells and getting your cells from commercial suppliers for most line cells don't know the sex of the cells. So there's a problem, but we are scientists, so we can solve this problem, because we cherish excellence. But it's also important to recognize that the bias in knowledge means bias in applications, and bias in innovation. And there are some examples at the bottom line. So, virtual reality, women suffer much more from travel sickness. Women have a 47% higher risk of injury in a car crash. In hip replacement, this was designed for hips that are like that and not hips that are like that. And there are also things about understanding the biology and when biology and gender are combined, which is basically the virus response to virus infections and vaccination policies. And Sabra Klein, who is one of the keynote speakers, will explain more about that. And I came across guidelines for studies on stem cells, and guess what? No sex or gender either. But there's also another issue, is the one about brain, MRI studies. Neuroscientists are particularly bad about accounting for the differences. They try to exaggerate the differences and minimize the similarities. Okay, so basically, you have like 1,000 citations for papers that speak about differences, and maybe like 10 or 100 on the papers that say that basically there's no difference between women's and men's brain. So, we have evidence, and this evidence is an opportunity. We have evidence of differences, and this evidence provides us with opportunities to provide better biomarkers for metabolic diseases, diabetes, heart attacks. We have now differences shown on a very biological level in immune responses in cancer. This is again an opportunity. Again, Sabra Klein will talk about the vaccinations, how you actually have to design vaccines for women and men. In the United States, between 1999 and 2001, 10 prescription drugs were withdrawn from the market, 8 were more dangerous to women than to men. That's because the toxicity models are based on studies of male rat primarily. And then we have this whole trend of trying to say that maybe we can't do this research involving male and female animals because that means we're using more animals, but there's of course a new process of changing how the research is done using lab on a chip. So you just put a few cells here from liver, from lung, or from another part of the body, and then you can measure the toxicity in there. But guess what? All the studies don't look at sex and gender, so they don't know what cells they're using, so we're getting approximate knowledge again. And it's very important for the use of all those omic technologies, metabolomics, genomics, and so on, because these XY chromosomes, which were thought to be like independent of everything else that was happening in the DNA, expression of DNA, actually they're all very active and influence what is happening. And then we go to the climate change. We have a model of the climate change produced by a big Lancet study on that's monitoring the impact of climate change on human health. They produced this really nice model, and 31 indicators of the impact, none of them deals with sex or gender. Yes? And so the opportunities come up. This were like, we have these new technologies being developed, which is the lab on a chip, and so we can use these technologies to measure the impact of pollution. We use, if we know which cells we are using, we can kind of measure the impact along the chain. These are all opportunities to create a new markets for science knowledge. But of course, science is not done by itself, it's done by people. And of course, the labs are dominated, especially at the higher level, are dominated by men. 70% of people around the world think that to be a scientist is to be a man. If we don't change this, we keep on helping propagate this kind of stereotype. In Tokyo Medical School, recently it was presented that great women at entry level, were entering to the medical schools, they were graded lower than men. Because it was worried that actually if you have more than 30% of women students, like the whole medical system will collapse when they all get pregnant. And so we have to look at it from the point of view, what is it that including women in the lab and in the decision making makes a difference? Well, it makes a difference with the collective intelligence of the teams. Not the individual intelligence, it's the collective intelligence. Because communication is different. Because people recognize the context. So that's the problem solving, how we solve problems. It's not in the brain, it's how we learn to use our brain. So if you look at this table, just concentrate on the numbers and the differences. These are results from when experiments go wrong. So when experiments go right, the way that women scientists and men scientists work in the lab is the same, because there's a protocol. But if frequently things go wrong, and you can see there, yes, should we abandon this experiment? Do we know why? Unknown. Okay, women thinks we don't know, men thinks, okay, we don't know, but doesn't matter. Well, let's just use another method, and we're going to proceed until we get the results we want. So this kind of observations that were done by scientists going into the lab and observing how people actually work, tell us, why is it important to have not only gender balance, but also the diversity of cognitive thinking, because we just prevent the cognitive bias entering into problem solving. And in this crowdsourcing situation, there is a website called innocent.com. Companies can pose problems that they don't want to solve themselves in their own labs. And that was studied by Harvard, showed that women outside the silos, outside the establishment, produce the best solutions. This is because they understand the context, okay? They have been trained as scientists and they understand the context because that's their life. So I feel now that it's time to add value to science, to create a new market for science knowledge, create a better knowledge, but also we have all those women, we want to get them into STEM fields. Women in society control more than $25 trillion of annual consumer budget. Why are they ignored as a market for science knowledge? Yes? We have to come to, in a traditional innovation system, there is this valley of death, yes, which is usually corrected by getting money from hedge funds and so on. But actually we can bring it more closer together by involving society and women and many other groups in the innovation process and making use of all the talent that is already there in the academic world. So this is really the lesson that I want to take you from to now for the rest of the summit, and hopefully this is something that will appeal, especially in Singapore, that prides itself on scientific endeavors. So enjoy this discussion. And please join the Global Gender Summit community, which is now 7,000 strong, so by subscribing to the newsletter. Thank you.